Good afternoon, everyone, and thank you for joining us this Friday lunchtime for a MachineMax webinar in association with our friends at Cemex. So today we're exploring the topic of productivity across heavy plant and machinery, and in particular the issue of machine idling, and how by addressing this issue it's possible to deliver significant savings in both fuel and emissions. So my name is James Atkinson. I'm VP for Global Sales at MachineMax. And before we get started, I'd just like to hand over to my fellow presenters so that they can introduce themselves.
Hi everyone, my name is Juliet Ransom. I am the Customer Success Manager at MachineMax, and today I'll be joining the webinar to show you a live demo of the MachineMax platform and how it can help you to stop idling and start saving.
Good afternoon, everybody. I'm Stephen Coles. I'm Operational Excellence Manager for Cemex, and Cemex have been working with MachineMax for about 18 months through projects in the UK and France.
Okay, thanks guys. So without further ado, let's get into the webinar. So we've split today's session into 4 key headings. Firstly, an introduction and background by myself, exploring some of the challenges that the industry faces. As Juliet says, then she'll be taking up the reins and demonstrating an example of how technology can drive productivity insights and measurable benefits. And then Steve will provide some context by sharing the learning he's gained working within Cemex. So just a quick note before we get stuck in. As we go through the session, you're going to be presented with some poll questions. We'd be very grateful if you're able to take a couple of seconds just to complete those answers, as we'd like to share some of those findings with you afterwards. And also, if you have any questions as we go through, please type them into the text box that's available, and we'll be monitoring those, and we have a section at the end for questions and answers. Okay, so at MachineMax, we've been conducting some research across quite a broad set of data that we have in our platform. So here we're looking at statistics across 1 month and 17,000 machines working in the UK. So what you can see, rather alarmingly, is the average utilisation of a machine is only 4.5 hours a day. And during that time it's being used, 45% of that time it's idling. So that's quite a shocking statistic, which can then be further backed up when we go in a little bit more detail here. So this is an HS2 project. Again, 1 month, September of this year, 58 machines being monitored. The average utilization here for a machine was 4 hours, and there was 1,703 idling hours in a month. So that's 17 tons of CO2s that have been produced from idling in just 1 month, which equates to 204 tons across those 58 machines over the course of the year. And then when we look at the cost of the fuel, £13,624 spent on fuel for idling, which again, when you work that up across the year, becomes £163,000 worth of fuel idling alone. Another example here, this one being a national highways project. So again, September, this is across 6 machines. The average utilization on those 6 machines was only 20%. And the idling time across that was 33% of that time it was idling. So again, big amount of CO2s needlessly being pushed out into the atmosphere, and a lot of money being burnt in terms of fuel costs. £2,792 in the month, or £33,000 over the course of the year. So that's positioning some challenges. So firstly, let's look at 2 standout topics, and I think the first one that we've touched on there is fuel costs. So fuel costs have been steadily rising. The legislative change this year, in April of this year, preventing construction businesses from using red diesel and moving to white diesel, that happened in April, and that increased overnight the price per litre of fuel by 58p. And then due to other economic changes out there, the price of fuel has now peaked at £1.96p per litre. So that's a tough background. And to put that into context, if you look at a Hitachi machine with a 400-litre fuel tank, in January of this year, it would have cost £360 to fill that fuel tank. July of this year, 704. So that cost comes straight off the bottom line, and it's quite a significant rise. And indeed, if you look into the press, you can see lots of news stories about the implications of how this is hurting the industry. Lastly, there, saying that 16,700 construction firms now at significant risk of closure due to the rising costs. So it's not just about fuel costs, it's also about the sustainability side of it and looking at emissions. So it's reported that over 25% of global emissions come from the construction sector. That's not all from plant and machinery, that's material production and everything involved in the construction process. However, 81% of CO2 emissions that come from plant comes from plant greater than 3 tonnes, which, to put that in context, is 10 million tonnes in the UK, which is 2% of our total greenhouse gases. Now, most customers that we work with are trying to reduce their idle time by 20%. The opportunity, therefore, following that through, is if we can reduce that by 20%, that's 2 million tonnes of CO2s that we can save from being pushed out into the atmosphere. So that all stacks up, and that seems to be pretty straightforward. So why isn't everybody doing that? And the challenge is the fragmentation of the data. Our customers are working in lots of different geographical locations, and in those locations, they're doing lots of different projects. And on those projects, they'll be working for different customers, asking them to report things in different ways. The machines that are actually on the sites, well, they don't own them all, right? So there's multiple owners of those machines. They'll own some, but they'll be hiring some in from plant hire companies. And those machines will all be different makes and models of machine, all with different connectivity. So there's a common theme across all of that, which is different. So being able to therefore analyze performance in a simple and easy way becomes very difficult because data is locked away in many different silos. So at MachineMax, we recognize that problem. And what we do is provide a platform, a single view of all your machine data, and we can pull data from any equipment, from any API, or from any sensor. So an open approach to data integration. We can pull the data into the platform, aggregate it and standardize it, and provide our customers with a single timely view of machine performance. So what I'm going to do there is hand over to Juliet, who will be just able to walk you through that. But before I do that, I believe that you've got a poll question there in front of you, which are, what are the biggest priorities in your business when considering equipment management? If you could just take a second to have a look at that and click on an answer, I'd be very grateful. So now I think we are handing over to Juliet.
Thanks, everyone. I just want to confirm, can everyone see the platform that I've shared? Looking good, James?
Yep.
Brilliant. Okay. All right, everyone. What I'm going to do today is I'm going to be taking you through live data on the MachineMax platform for Cemex. The use case today is essentially that I am a site manager on the Arnville site, and I'm analyzing what has happened on my site yesterday. My aim is to identify inefficiencies and increased idling on my site to understand where and why it's happening, and hopefully implement something that can reduce that idling and therefore reduce the cost of fuel and the CO2 emissions that machines are emitting on my site. So by using MachineMax, and in particular our Max Tracker sensor, what we're able to do is we're able to collect data off of your machine. That data includes activity data, so active hours, idle hours, off hours, as well as live GPS, okay? What this enables you to do is it enables you to look at your site from a high level site perspective, full connected site, and then drill down into where your efforts are best placed in order to reduce idling and therefore reduce cost in CO2. So, like I said, I am taking a look at the Anvil site and I have filtered to the date of yesterday. What we can see is that I had 6 machines on my site. I had a utilization of an average of 90%, which has increased from the day before yesterday, which is Wednesday. I can then see that even though my utilization has increased, my idling activity increased by 27% from Wednesday to Thursday. So let's try and figure out why that happened. First of all, what we're seeing in our first widget on our dashboard is a 7-day rolling idle trend. It's basically reaffirming what we see with our trend data here, is that for the last 3 weeks, we've seen an increase in idling on this site. From here, the next widget I'm looking at is our activity by category. So what this does is that it lumps all of your machine activity into the category of machine type. And this can start to show you what type of machine is contributing to the most amount of idling on your site. So from this, what we can see is we've got 3 loaders at 95% activity. So for yesterday, there was only 33 minutes of idling for those loaders. Whereas in comparison, we look at our telehandlers, our 2 telehandlers, only at 76% utilization with a total of an hour and a half worth of idling yesterday. And we can see that our 1 tractor did not work yesterday. So by looking at this widget, I can see that my efforts are best placed as a site manager in the telehandlers to reduce idling. There is no point in me looking at my loaders because reducing 33 minutes of idling is not going to bring me the biggest benefit in terms of cost reduction and reduction in CO2. I can then drill down from activity by category into individual machines. So looking at yesterday, I can see that I've got my top 5 lowest utilized machines. We've got 5 machines noted here, but I want to focus on the specific machine that is causing the most amount of idling on my site. And that is this machine here. We can see that yesterday it worked for a total of 5 hours. And of those 5 hours, 3 of those hours were active and 1.5 of those hours were idling. Okay, so that brings us to a utilization of 69%, which we can see is vastly lower than the remaining 3 machines here that are within our lowest utilized machinery. Okay, so what we've done is by using the dashboard, we've taken a look at the site level and we've drilled down to figure out what is our individual machine causing us problems. Okay, so now let's look at that individual machine to figure out exactly what's happening there. With the MachineMax tracker sensor, like I said, it gives you live GPS and it gives you active versus idle hours. Now, as we all know, that on a site, you have different kinds of idling and you're never going to be able to run a machine without idling. So this is where MachineMax comes in to define what is operational idling versus what is non-operational idling. As a default for this site, what we've got is we are showing idling that is taken place for 5 minutes or more. Any idling that has taken place for 5 minutes or less, we are showing as active because we see that as operational idling. We want to help you identify the non-operational idling so that, again, your efforts are best placed and that you can have the biggest impact on reducing idling that is not related to the operations that you have. So I can see here that for yesterday, we started the day out and we've got a few instances of idling over 5 minutes. Here we can see idling for 8 minutes, 11 minutes, 12 minutes, 23 minutes, 24 minutes, and 19 minutes. These idling here for 11 and 8 minutes are maybe not so much of a concern. However, the 23 and 24-minute idling segments are definitely a non-operational idling and could definitely be reduced to increase your utilization and efficiency of this machine. So this might tell you a few things as a site manager. Perhaps between 11:13 and 11:36, this was a lunch break, and your operator left the machine idling during this time. You could then reduce the idling by telling your operators, please switch off the machines when you are taking your lunch break. So now we know when the activity is taking place and what kind of activity is taking place. But what about the where? Knowing the operations on your site and where the operations are taking place is key to understand the behavior of your operators as well as your machines, all right? So we've got this great feature where we can show a location of the activity that is happening on the site. Okay, so we're looking at an individual machine here for yesterday. This is our top idling machine. And we can now drill down into where did this 23 minutes of idling take place. So if I click on my 23 minutes of idling, I can see that this took place in this area here. If we look at our 24 minutes of idling, it's happening over here. And then our next biggest is our 19 minutes of idling, back down in the same area as the 23 minutes of idling. So now we've established, okay, idling is happening within this area and this area up here. So what does that mean? As you can see on this map, we have some geofences, right? If I go into this individual machine and look at the geofences and the routes of this machine, I can now understand why is the idling happening in these particular areas. As we can see, the geofences are showing me that this area up here on this site is a dumping area, and this area down here is a loading area. So the 23 and 24 minutes worth of idling were happening within the loading area, okay? This could show various things. This could show perhaps there is a delay in the telehandler loading up before it goes and dumps the material in the dumping area. It could perhaps show a bottleneck in your efficiencies around your loading area where your telehandler is having to wait before it can load up and dump in the dumping area. The 19 minutes of idling that we saw within the dumping area could also show an inefficiency in the dumping area. Maybe you had telehandlers lining up and waiting to dump, and therefore that caused the telehandler to idle for 19 minutes. Okay, so here what we're essentially showing is we're essentially showing the story of your site, okay? We can see that for this route in particular, I'm looking at this trip. This trip took 10 minutes from 1:02 to 1:12 yesterday. They started in the dumping area, they went through to the loading area, and then all the way around to the site office parking area. Okay, so this is telling you the journey that your machine has taken. And this can tell you a few things. Did the machine take the most efficient journey, or is it taking the long way around and therefore using more fuel? Okay, so we're starting to understand the story of the site here. What else can MachineMax do in order to tell you what's happening on your site and the idling that's going on? We can also show you what we call an idling heat map, right? So here we have the site again with our geofences. Okay, our geofences again are our loading area and our dumping area. And we can see the highlighted heat map area of your idling. Okay, so we're looking at the minutes of idling, and we can see that the most amount of idling is taking place in your loading and dumping area. This is expected from a site. You would expect your idling to happen in these areas. However, let's say, for example, that there was a highlighted area of idling over here or around the turnaround area on your site. This can help you to identify where inefficiencies are on your site in terms of the routes that are taking. Are the roads not graded enough so that your machines are having to wait in order for them to get over a certain route? Things like this, visually, we can show you. The last thing I then want to show you is our map and locations feature. So this, I'm going to filter to today, and I'm going to show you the benefit of having live data. Okay, I've enabled our geofences and I've enabled live updates here. As we can see, this is a working site. Here is the machine that we were looking at to try and figure out the inefficiencies of idling. And the machine is currently, as we speak, in the loading area. And we can see that this machine is now moving, probably going back to the dumping area. So this is a live view of your site. So as a site manager, what have I been able to do? I've been able to look at yesterday's workings. I've been able to look at the full site, drill down into the individual machine that's causing the problem. I've then been able to look at the machine that's causing the problem and understand where the excessive or non-operational idling is taking place on the site. I've then been able to collate that with the highlighted heat map of idling to understand, okay, the idling is happening where it is meant to happen. And now as a site manager, I'm able to see a live view of my connected site to understand if this machine is behaving in the same way as it did yesterday. And as we can see, as we've been on this map with the live updates, we've seen some machines moving around and working. This machine, again, is standing still within the loading area. So I can assume by looking at this live update that this machine is behaving in the same way as it did yesterday. We are still stopping and idling in the same loading area. So now as a site manager, I can understand, okay, I need to either talk to this operator of this telehandler, or perhaps I need to understand what does this telehandler need in order to reduce that idling within the loading area. All right, thank you very much for my time, everyone. And we're going to hand over now to Stephen, who's going to take the next session. And first a poll is going to take place.
Okay, thank you, Julia. Just to give you a quick background into Cemex, so for those of you who don't know who Cemex are, Cemex is one of the largest cement manufacturers in the world, and we also provide ready-mix concrete and aggregates. We currently operate in around 50 countries across the world and employ about 41,000 people. Like most companies in the current climate, Cemex has just launched what's called Future in Action, where we're committed to reducing net zero CO2 by 2050 and to reduce our fuel usage by 40% by 2030. So all the things that we've sort of been talking about today, it's very relevant within our business that people like MachineMax are helping us to actually look at our idle to reduce our fuel usage and our CO2. So in the UK, we currently operate about 500 pieces of mobile equipment from mixed OEMs, and 3/4 of our carbon footprint is actually made up from diesel usage from mobile plant. We run a whole range of different types of mobile equipment, from dump trucks to wheel loaders to excavators and tractors, pumping we do as well. So one of the biggest challenges that we face is that with all these different OEMs is that they all provide a different type of data to us. That it causes a lot of issues, because when there's about 50 different types of manufacturers to actually go into these portals to download the information, we don't see a clear view. Also, one of the other challenges that we face is that they all seem to provide different data or different algorithms on idling, what causes another issue, because we start to see machines where we think is very good against another manufacturer, and in fact the other manufacturer may actually be the worst machine. We just don't know that because of how they calculate their idle time. So I was going to talk about something slightly different, and it's kind of what Cemex do with the data that we get from the likes of MachineMax and how we actually try and improve on our idling. So I've listed sort of 8 categories where we sort of focus our efforts into. And when I talk to people about idling, the first thing a lot of people say to me is it's just fuel reduction. But when we actually break it down, there is a lot more in savings than just fuel reduction. So the first one, what we always see as our quick win, is driver behavior and training. And this is where if we didn't have the idling data, we can't really challenge people on exactly their performance and what they're doing. So when we get the data, we're able to sit down with the team and discuss about their idling for that day, that week, and one of the things that we've have introduced before is league tables. So it's there's a bit of competition sometimes because you don't want to be bottom of the list of being the worst offender. So that also helps when we get new employees. They can be trained, have their certificates to say they can drive a wheel loader, but sometimes they don't understand how detrimental it is to our business when we're sitting there and idling for a long time. Fuel reduction, obviously, as James alluded to earlier, the price of fuel is increasing all the time. So, a basic machine will idle for 1 hour, uses around 4.5 litres of fuel. And at the current prices, that can be up to about £9 for every hour for that machine sitting there. And as you can imagine, just in the UK alone, over 500 pieces of equipment, if they all idled for one hour a week, that's quite a large amount of money that we're wasting. CO2, as I just said, we're committed to reducing our CO2 significantly in the UK and abroad as well. There are different levels, what we're also starting to see now is that the local councils are wanting a CO2 reduction roadmap. So when we're applying for planning conditions, or even when we're bidding for work, they're asking how we're going to reduce our CO2. Clearly, when we have the idling data, we're able to challenge our operators and reduce their CO2 and their fuel usage. As a business, we want to run efficiently as possible, and when we're idling, we're not being efficient. But there's another element to that, is that when our machine is inefficient, also our operator is inefficient as well. That talent is being wasted sitting there whilst the machine is idling. So we want to try and avoid that as much as possible. And again, using the data, using the heat maps, as Juliet showed, we're able to try and engineer out some of their inefficiencies by changing routes of the workplace that we're moving around in, or even down to equipment as well. Service costs is something that I think is not really highlighted when we talk about idling. And the difference in a mobile plant compared to a car is it's done on hours. So in a car, you drive 10,000 miles, you have your car serviced. In a mobile plant, it's usually generally about every 500 hours. And unfortunately, when that machine is sitting idling, that is also, the clock is ticking. So we're using that time, and it's making that service actually inefficient, because a proportion of that time is being wasted through idling. So your service costs and to your actual productivity is reduced. Increased engine wear as well. So when we're idling, we're also increasing the engine wear because we're not getting the airflow through the machine as it normally would when it's moving. So again, we're not getting it reduces the lifetime of the asset, so we're not maximizing our investment in that piece of equipment. Correct machine sizing as well is another classic one that we've able to be seen from the data that we get from MachineMax and looking at the idling. If a machine is too large for the job and sitting there idling, there is other benefits from not just from fuel or the CO2, but we could reduce the lease cost of that machine by putting a smaller machine in. And again, all these things listed contribute to savings. And without any of this information, we are very blind as a business to see how inefficient we can be at times. And I'll give you a great example. When I first started at Cemex, on one of the sites I was looking after, we had quite a large Volvo loading shovel, an L220, and we looked into the efficiency of the machine, and we see that every other machine on site was around about 20% idle time. Now, this particular machine was up to nearly the 50%. We went down to the operation and looked at it, and what we actually found was the feeding hopper was very, very small for the type of machine. We couldn't re-engineer the hopper at the time, so we reduced the machine down to an L150, so a much smaller bucket. The operator didn't like it because he had to work a little bit harder, where he was quite enjoying sitting there just tipping in the material very slowly. But to give you an indication, within a year we saved just over £20,000 on that just one machine from that one little change. It's a significant saving. We reduce their CO2, we reduce their fuel usage, and we reduce their lease cost and their service costs. So getting data is brilliant, but it's what you do about it. And you know, one of the things that we've been very quickly, what we've found, and obviously what Juliet's presented today, is that we can break down the idle time, and we can work out where our inefficiencies are within the business. And it's all about asking questions and actually trying to deliver something at the end of it, because we can pay for data, but the main thing is you have to react to it. And it's keeping the focus. One thing we've also found as well is that it's great at the beginning, you get a lot of momentum, but it's keeping that momentum. So you know, we have to do regular meetings with our team. We have to do regular reviews with the likes of MachineMax, who then help us as well. So working together, we've seen significant savings. We've reduced our fuel usage and we've reduced our CO2, what meets our global targets. Thank you. And back to James.
Thank you, Steve. That's a fascinating insight and really brings it to life. So thank you for that. So lastly then, just to wrap up with a quick summary and a few thoughts. So I suppose the key phrase is you can't manage what you can't measure. So what are the priorities and how would you do this? I think the first thing to think about is why. What are the key drivers? What are you looking to achieve? We've talked about increasing costs and particularly fuel costs. So reduction in fuel use, reduction in fuel costs is going to be a key one. Legislation, so sustainability, net zero legislation, or internal priorities around that side of things, or embracing digitization to connect your sites and use technology to drive out benefits. Then we need to think about what are you going to measure. So we're going to measure the fleet, its utilization, its productivity, but we've also said today that's not the full story. Let's have a look at the site. Is the site impacting the productivity of what's going on? Operator behavior. Can we improve the way the operators are working and provide them information to do their job better? Then we need to prove it, okay? So it's all good in theory, but we've got to prove it. So prove some benefits, define the processes. Steve's alluded to how they did that within Cemex, and then off the back of that, the solution gets rolled out and is continually reviewed and continue driving to ongoing improvements. So lastly, I think we have some questions from the audience. So I think my colleague Dane has been capturing these as we've been going through today's discussion. Dane, is there any questions that you would like to ask?
Hello, everyone. Yes, we had a few questions in, so thank you for sending them in. The first one is for you, Juliet, and it's how do you train your team to ensure they are getting the most out of the MachineMax platform?
Great question. So I think first and foremost, what we need to understand is we need to understand the pain points of the specific site, right? Depending on what the site is trying to do, will then depend on the training that that site receives. With MachineMax, myself and my customer success team are dedicated to training those on site to use the platform in the best way possible. Like I said before, you know, it also depends on who you are on site. If you are the site manager or you're the regional site manager, you might want a different view of the data depending on what you're trying to achieve. But like I said, every use case is different, every site is different. But the main thing is that we need to understand what your pain points are in order to successfully address those and help you to understand the data in order to identify the inefficiencies and the solutions available to you.
Brilliant, thank you. Now just a quick question for James. What integrations are important when selecting an equipment management solution?
Okay, so I think integration is key, and I think Steve alluded to this when he talked about how many different OEMs, how many different makes and model of machine that he has across his business. So having an open approach to integrating, being able to pull data from any source is fundamental if you want to get a full and clear picture of your full fleet. So yeah, I would say that that integration is absolutely a key topic when you're looking at how to address this issue.
Perfect. And then just one final question for Stephen, and this is pretty simple, but why did Cemex select MachineMax?
The reason probably why we selected MachineMax was because we were able to integrate a mixed fleet of OEMs straight off, and also we didn't have to worry about any machines that didn't have API feeds, and this was one of the big sort of pain points that we had, that we just didn't have a platform that we could integrate, you know, as many OEMs as we wanted into a single pane of glass. And you know, the guys have been absolutely brilliant, and I'm not just saying that because I'm on their call, but the ease of installation, you know, you can do that yourself. We don't have to have specialist people come to do that, so it's reduced their costs. And the platform itself, visually, is one of the best that we have seen, and we've researched for a lot of different companies to find something. Visual management is the way forward. It's very clear, very easy to navigate. So there's lots of what we found as plus points, and that's the reason why we chose MachineMax.
Brilliant. That's all the questions. And just back to the final thoughts from James.
Thanks, Dane. So it just remains for me to thank you on behalf of both MachineMax and Cemex for allowing us some of your valuable time today. We hope you found the discussion useful, informative, and please keep an eye out for future webinars where we'll be picking up on a variety of key industry topics. So you can learn more about MachineMax by following any of those links that are on the screen, and we'll be sending out a link to today's webinar so that you can revisit that as required. So thank you all, and have a great rest of the day. Thank you.